Hi friends, this is S. Geeta Priya from Welltech. Myself along with my friends K. Sublakshmi and Y. Divya, we had done a final year project. Our project is in VLSI domain and our project title is Design of Power Efficient Content Addressable Memory using memristor and MTCMOS in FINFET Technology. In our project, we are going to design content addressable memory uh, using FinFET and memristor and MTCMOS. Content addressable memory is a special type of computer memory used in high-speed searching applications such as translation lookers, buffers, network routers, database accelerators, etc. It is also known as associative memory. In CAM, the additional circuitry for data comparison increases physical size and the power dissipation. Hence, we go for certain alternatives. And also the current trend is to have devices not only smarter but also compact. For this the chip size must be reduced. This can be achieved by transistor scaling. But the problem is when the transistors are scaled below 45 nm technology, the conventional CMOS fails to operate because of short channel effects. To overcome these effects and to reduce power dissipation from the several alternatives available, FinFET proves to be more efficient in reducing the leakage current. So we are in our project we are using FinFET instead of conventional MOSFET.
FinFET is similar to MOSFET. The only difference is that the channel is covered by three-dimensional gate called FinFET and it isolates source and drain. But CAM is non-volatile. In order to have volatile, memristor is used to retain the data when the device is not powered. In order to reduce the leakage effect during idle state, power gating is achieved using MTCMOS technique. Thus, our project is to design a power-efficient content addressable memory using memristor and MTCMOS in FinFET technology.
This is schematic diagram of CAM using conventional MOSFET. Here the CAM itself consists of two main parts, that is storage unit and comparison circuit. The storage unit is the one in which the data is stored. The comparison circuit is to compare whether the search data is matched with the stored data. The storage unit is made of typical 60 SRAM cell. The comparison unit is made of XOR and XNOR matching circuitry for data comparison. The NOR CAM bit cell using conventional MOSFET has cross-coupled inverters and transistors M3 and M4 that forms the storage unit, while M5 to M8 transistors form the comparison unit. The same NOR binary CAM bit cell is designed using SG type FinFET. Here, this is a schematic diagram of CAM using SG FinFET. Here, M1 to M6 forms the core SRAM cell, while the transistors M1 to M10 forms the matching circuit. This is the proposed architecture of CAM using memristor, in which memristor is used in between the VDD and the drain of M1 and M3. When the VDD is on, the memristor will be in cutoff region. When the VDD is off, it goes to saturation region and retains the data in the CAM cell. Even though the CAM using memristor is efficient than the previous design, the leakage still exists. When the device is ideal, the leakage power increases. So there is a need to turn off the device when it is idle. In order to achieve this, it must be isolated from the power rails. Here, when the clock is given high, the device is connected to the power rails and it performs normal operation. When the clock is given low, the device is isolated from the power rails, thus reducing the leakage power. Thus, by both memristor and MTCMOS, an efficient CAM can be designed.
The simulations are carried out in Tanner EDA tool in 22 nm technology. For 22 nm technology, the VDD must be given 200 millivolt. This is the conventional CAM using MOSFET. Here we use MOSFET, and in our this is the CAM itself using FinFET. The same design is designed using FinFET, and the proposed design will have a memristor in between the VDD and the drain of M1 and M3. Here, this is the memristor which is going to be added in the conventional design. Memristor is designed in 32 nm technology. The memristor block is this is the memristor block. We have included this in our conventional design. And another additional thing we are added is the MTCMOS. MTCMOS is used for power gating, that is to reduce the leakage effects during idle state. We are using MTCMOS. Here the MTCMOS is an high VT PMOS and an high VT NMOS is added in the circuit. So whenever the device in idle state, the leakage effects will be reduced. This uh, after uh, after after drawing the circuit in SED tool, we get the output in WEdit waveform and the power values in the T spice. The operation of the cam using conventional design and proposed design must be same. The only difference, it has to be change. It has to reduce the power values. This is the output of NOR cam bit cell using conventional design, and this is for the proposed design, and this is for the proposed design using memristor and MTCMOS. Then we go for the table of comparison. In the table of comparison, we have compared the designs using MOSFET, FINFET using memristor and MTCMOS for three different temperatures: 20 degrees Celsius, 40 degrees Celsius, and 60 degrees Celsius. Here we can see that there is a gradual decrease in the power value. The main aim of VLSI design is to reduce the power, and hence here in our proposed design there is a decrease in power. This is the bar graph showing the gradual reduction of power. The blue color graph shows the existing cam cell using FinFET, and the red color graph shows the proposed cam using memristor, and the green color graph shows the proposed cam cell using memristor and empty schemas. Thus, by our project, the main disadvantage of power dissipation has been reduced. Thank you.